Analysis of cheetah's motion. The position function of a cheetah moving across level ground in a straight line chasing after prey is given by the equation s of t equals to t cube minus 15t squared plus 63t, where t is measured in seconds and s in meters. When is cheetah momentarily stopped? Part B is, what are the positions of cheetah in part A? And then we have model the path of the cheetah, and part D is, find the total distance traveled by the cheetah during first 10 seconds. Well, with the help of this example, we'll try to understand many concepts regarding position, velocity and acceleration. We'll also understand when the position is increasing or when the distance is increasing or decreasing. And we'll also try to understand when is something speeding or slowing down, right? So we'll have a couple of videos on this. Now this one is when we want to figure out from the displacement when is cheetah momentarily stopped. Cheetah will be momentarily stopped if velocity is 0, correct? So let's find the derivative of this. So derivative of s dash t is actually velocity. So velocity is actually first derivative of position. So this is t cube minus 15t squared plus 63t. So when you find derivative, you get 3t squared minus 30t plus 63. So that is the derivative. Now when we say when is cheetah momentarily stopped, that means vt should be equals to 0, right? So we should now factor this and then find out when it is 0. So we can factor out 3 first. And what do we get? We get t squared plus 10t and 13 right. So if you divide 63 by 3, you get 21, not 30, 21, right? So this is 21, right? So you get t squared plus 10t plus 21. Now let's factor this. So it is 21 is 7 times 3, right? So we can write this as t plus 7 times t plus 3. So that is the factored value, and obviously this is 0 when t equals to 7 or t equals to 3. So when is cheetah momentarily stopped? The answer is at t equals to 3 and at t equals to 7. So these are the two positions when cheetah is temporarily stopped. And now we have, what are the positions of cheetah in this part, right? So positions means displacement. These are the times, t values. So we can find what is s of 3, plug in the value here, and what is s of 7. This is what we'll find out now, right? What is s of 7? So s of 3 will be, let's use the calculator. So we get 3 cube, which is 27. Let's use calculator. So we'll find, okay, so we have minus 15t squared, which is 3 squared. Okay. So when we plug in these values, we get s of 3 is equal to 81. Right. So to find s of 3, what you can do is you can just plug in the values and calculate. So 3 cube is 27, right? 27 minus 3 square is 9. So 9 times 15. Let's write 15 times 9, and then plus 63 times 3, right? So let's calculate using calculator, which is 27 minus 15 times 9 plus 63 times 3 equals to 81. So we can write 81 here. Now s of 7 will be, you can plug in the 7 values here, and then you get 7 cube minus 15 times 7 square plus 63 times 7, and that is equal to So let's use calculator to find this value. 7 cube minus 15 times 7 square plus 63 times 7 is equals to 49. So we get S of 7 as 49 and S of 3 as 81. So what are the positions of cheetahs in part A? So at 3, when it is stand still momentarily, it will be 81. And the displacement at t equals to 7 will be 49. Model the path of the cheetah. Now it really means that we are assuming this moving along a level ground in a straight line. So it really means that at these points there is a turning point, right? So the cheetah is moving along a straight line and S3 is the turning point. So let's say this is the starting point. If t is 0, what is S of t? S of t is also 0. So we can write this as at t equals to 0, S0 is also 0. So that is the starting point 0, 0. Now at S3 we find that the displacement is 81. So cheetah moves like this in this direction. And let's say this is our S3. So at t equals to 3, S is equals to 81. So that is the displacement, right? At this point, right? Now at this point, actually it turns, right? And then turns back. S7, that means 3 plus 4. So after 4 minutes, let's say, so it should have gone further down, but the displacement is 49. So it's somewhere in between, right? So let's say this is the point where it stops, 49, and that happens to be another turning point, right? So now we have moved. Let's say it's this the point. So this is point, and then it goes back in this direction. Now at this point, we have t equals to 7, and the displacement is always from the initial position, is s equals to 49. Correct? So that is the kind of path it follows, right? Now let's see, that means it starts at t equals to 0, goes in one direction, which we are calling positive direction, for 3 seconds, and in these 3 seconds distance covered is 81, and then from there it turns back, and after, that means after 4 seconds, which makes it t7, it is now from initial position 49 units away, meters away, right? And then again it turns. So that is how it is. So the displacement at t7 is 49, displacement at 3, s equals to 81 here. So that is kind of our path. Now find the total distance traveled by the cheetah in first 10 seconds. So we have already found up to 7 seconds what is the displacement. So what is the value at t equals to 10? Let's find that out. So s of 10 is equals to 10 cube minus 15 times 10 square plus 63 times 10. And let's calculate this value. After all, what is t of 10, right? So when you calculate this, you get 10 cube minus 15 times 10 square plus 63 times 10. You get 130. So this is 130. Let's say this point is here, where t equals to 10 and displacement is equals to 130. Okay. Now what you see here is that the displacement is 130 at the end of 10 seconds. The question is, find the total distance traveled by cheetah. Now total distance traveled by cheetah is, if you see from here, it moves 81 units in one direction, right? So let me write down total distance. So total distance will be 81 first, right? And then it comes back. So when it comes back, the distance left is 49. So 49 is from 0 to here, right? So how much is this distance? That is what you need to figure out. So this distance is actually 81 minus 49, right? So that is the distance it covered. Now, and at the end, it is now from 7 to 10 seconds, it is from 49, it moves to 130. So the distance covered in this particular case is 130 minus 49, correct? So that is the total distance covered. Now let's calculate this distance, which is 81 plus, I should say 81 minus 49 plus 130 minus 49. And we get a total distance of 194. So 194 meters is the total distance covered by Cheetah during this time, right? So what you realize here is total distance covered and displacement are two different things, right? They are not the same things. They are two different things, right? So basically, in first 3 seconds, it covers a distance of 81. Then it comes back and it covers a distance of 81 minus 49. That is the second unit. And then from 49, it moves to 130. So during this time, it covers additional distance of 130 minus 49. So the total distance covered is 194 meters. So in 10 seconds, total distance is 194 meters, whereas the displacement is only 130. Do you understand the meaning? So that is how the two terms, total distance and displacement, are very different. Displacement is a vector quantity. So it tells you the difference between initial and final value. Distance, on the other hand, is a scalar quantity, which is the total distance traveled. So this plus this plus this, right? So that is what you should keep in mind when you're working on these kinds of problems. I hope you understand. Thank you.